Hello, I'm Hollylynne, and I'm here with Roger, Chris, and Maryann. And we're going to really focus on kind of advice for making inferential reasoning kind of a natural part of our practice. And I'd like to start out with a question about what do you consider to be the difference between informal and formal inferential reasoning? And I'm going to start with you, Maryann.
Okay, great. So informal inferential reasoning is something I've thought a lot about, as it turns out. The way I would characterize it is that we're not going to end up with a p-value, which is like some kind of formal measure of how likely or unlikely something is. We're just going to reason about the data. We're going to reason with visualizations and data displays, and we're going to coordinate some key concepts. We're going to coordinate concepts related to measures of center, variance. We're going to look at the shape of the data, and we're going to look at all the relevant aspects of the data to formulate some kind of prediction or conclusion, which of course we can't ever prove, right? So it's just reasoning and kind of putting together the key elements of the data that pertain back to the context and the question that's being posed. So not all the data is important every time, and I think that's hard sometimes for teachers and students and everybody to kind of reconcile with. You might have a question that's posed that's focused more on variation, and so you'll care more about the variation in the data. You might have one that's more about comparing measures of central tendency. You might have one that's focused more on the shape of the data. So you want to tend to different elements, coordinate them together to come up with some kind of generalization about the data, right. Beyond the data at hand to a wider universe. So formal to me is you run a hypothesis test or maybe conduct a simulation using technology to generate a probability distribution, and so you're ending up with some kind of number at the end that you can report in terms of what the likelihood is of something being true or not. So informal, I think, is more reasoning and trying to make sense of it without the numerical answer at the end. But you might use statistics to get there. You might use medians and means and measures, right? You might use measures. The last thing I would say is that, of course, it can't involve local comparisons. It needs to be global, right? Global comparisons of data distributions, and that's hard at times. So for teachers just starting off on this, if you have students who are reporting on specific data values, that probably isn't informal inference. So sometimes I think it's hard to tell where to draw the line. Like, is anything a student says about the data, is that informal inference? How do I know when I've got one versus when we don't, right? And so I think it's looking at the data distribution characteristics.
Right. So instead of kind of calling out some of those special cases and those outliers of, there was one boy that was so much faster than all the girls, so boys are faster.
That's right. You will hear that. Yes.
That they have to start. In order for it to be inferential reasoning, they need to be considering the whole data distribution.
Yeah, looking for trends and aggregating those ideas. So
right. So would you like to stem from that, like the difference between kind of informal to formal?
Yeah, more at the university level. One of the things that I guess I think of is the understanding of the process to, how would you think about the statistics? So if you are wanting to make this comparison, what would be an appropriate simulation kind of thing, so that you really have, even if you're not going to conduct a formal hypothesis test or do something like that, if you just wanted to look at it and say, is this something that would happen by chance, how would you build that distribution? And that's something that sometimes, we don't want to go to all the calculation details and do all of that. We just want to look at it and say, okay, convince me. Right. Even if I'm not going to go anywhere with that, and I'm not going to publish this result or anything like that, just convince me that this value is not something that would happen by chance. Well, how do I build that?
Right.
I can't add anything to this. This is fantastic. I think the only thing I will add, just to connect it back to the standards, when we discussed in a previous video about this idea of meaningful difference when we were comparing groups at the middle school level, to me that was the intention of the writers of the standards, to try to help students at a very early age get into this role of informal inference where they're using graphs and they're not going to p-values or they're not going to margins of error.
Right.
Come up with convincing arguments using your measures of variability and center as to whether this is meaningful or not.
Yeah,
and
right.
then once you advance up to where you're using simulation or using formal probability distributions and you get these measures like margins of error or p-values, then I always like to say you're thinking about is there a meaningful difference versus is it statistically different?
Yeah.
You know, as a way to distinguish the informal from the formal.